So one huge problem with artificial intelligence is that even though computers can compute things faster than people, they are really, really dumb. Your average baby can distinguish a square from a circle and a teddy bear from a truck, but it isn't so easy to make a computer do that. For example, think about mobile games or DS games where you had to use the touchscreen to draw or write. It didn't always understand what you were trying to do. Computer vision is also especially applicable to augmented reality gaming, like Microsoft's Minecraft demo on that coffee table. The headset sees a 2D image of pixels, not a 3D world, so we have to find ways to predict where the table or the floor is and how we should render the game on it. There are tons of other cool things in this area, like automatically creating 3D models based on 2D photographs, which could be used to build cities or simulate medical procedures. But let's start with a simple problem: classifying images. Image classification is a big deal because, as said before, it's very hard for computers to distinguish things that the average 2-year-old can. Google has invested a lot in this, especially with their new image search, where you can search by uploading an image to figure out what it is. Of course, this is still a little bit experimental because it's definitely not been perfected. Why? One of the most classic examples is classifying dog breeds. If you take 1 million pictures of dogs and average them out, you could get something that looks like this. In the human brain, we have prototypical images of different words like dog, cat, building, car, banana. These are the most standard or basic pictures of those things. If we see an image that looks like this, we can quickly identify it as a dog. But then you have some oddballs like this or that. And while most of us could still identify it as a dog, experimental evidence shows that we have a slightly slower reaction time. Similarly, you could imagine that it's a reasonable problem to have a computer know that this is a dog and this is a sheep, but it gets harder with non-prototypical dogs. And even further, what about distinguishing between a Labrador and a Golden Retriever? From these images, I'm sure you can determine which one is which, but what are geometric measurable features we can isolate? And how could we generalize this to images at any angle with any background? Solving this problem would solve many others. If we can algorithmically distinguish dogs, then we could do the same for cars or flowers or human faces. But to see how we could do that, let's scale this back to something simpler, like numbers or the alphabet. If we write a sentence or a number on a touchscreen by hand, how does the computer translate it? Let's say we have a huge data set of handwritten numbers. They all look somewhat different, they're prone to human error, and they've been manually assigned labels, meaning someone scrolled through each image and entered which number it represented. And there are only 2 colors to worry about: white of the paper and the black of the ink. So now we have what's called a training set in machine learning. We can use this training set to develop a distribution of probabilities for each pixel. For example, after analyzing 1,000 or 10,000 images of each digit 0 through 9, we might get something like this. These are heat maps, where the red represents the probability a pixel is black at that spot for that number. Now let's say we have some image of a number that we want the computer to identify based on our training data. So we look at each pixel in this image, the test image, and look up the probability that it could be each digit. So if 98% of all samples of our training data for the number 1 had a black pixel at a certain position, we'll be slightly more biased to classify it as a 1. If 10% of all samples of the number 5 had a black pixel at that same location, we'll be less biased towards classifying it as a 5. We add all of these percentages up for each pixel and each digit, then pick the digit that has the highest total probability based on all of the pixels in the image. This is known as the naive Bayes method, and because it's naive and a bit simplified, it can often classify things incorrectly. One I made for this exact problem is about 75% accurate. You can see here's a heat map of the odds ratio of two commonly misclassified numbers, 9 and 7. You can see how they're pretty similar. A 9 is kind of like a 7 with a closed loop. So here the red pixels are those that are very likely to indicate the image is a 9 if they're set, while the blue indicates features that are more distinct to the 7. This makes sense, I think, since the 7 and the blue pixels are a little bit elongated to the left, and the 9 has that kind of bottom loopy part in red. You may now be able to think about how we could develop more advanced ways to recognize things like dog breeds by measuring the probabilities of different features in those images. Of course, that kind of image recognition requires some more advanced systems. Google's crazy cool Deep Dream algorithm, which made pictures that were on LSD, uses neural networks, or deep learning, to identify these patterns and features in any type of image. You could say a deep dream image is like a visualization of how the neural network analyzed it. Its training set was actually primarily dog breeds, which is why everything seems to morph into a dog. If it were trained on other data sets like flowers or boats, we might see more of those images, but it's very difficult to get millions of human-labeled images to produce meaningful results. In fact, you could make a small amount of money helping to label these sets on websites like Mechanical Turk. It's something that pretty much every human being can do, but it takes a lot of manpower. Another cool tidbit is that the reason why it looks like a drug-induced hallucination is because of how neural networks and computer vision loosely mirror our actual visual cortex in our brains. Deep dream images are over-processed to strongly identify patterns, which is similar to a human on drugs, where certain neurons fire more and cause people to fixate on specific images or experiences and distort them. There isn't much formal research on that, I'll be honest, but it is an interesting theory as we try to create more human-like AI systems to solve problems. In a general, vague sense, it at least shows that overstimulating an AI's brain does similarly weird things as overstimulating a human brain. So I hope you guys found that interesting. I know I think this field is awesome, and you can probably tell there's a lot to this topic and many others I covered, which is why I've actually decided to move a lot of the straight up coding and advanced math to a dev stream I'll be starting on Twitch. I'm thinking of uploading key points or like a programmer's highlight reel to YouTube, and we'll see how it goes since I really have no idea what I'm doing. So follow me on Facebook and Twitter to get updates on that. I'll definitely make more videos on YouTube on advanced topics here, but in terms of working through the math and code specifics, I think the slog works better in a longer format. But who knows, right? Anyway, guys, hope you enjoyed this video. Let me know if there are any topics you'd like me to talk about. Have a happy day wherever you are. I'll see you guys on the stream.